I was informing you that it was all about making sandwiches. I wanted you to make sandwiches. And let's say that I started you out with maybe 3 pieces of meat and 4 pieces of bread. So 3 pieces of meat, 4 pieces of bread. How many sandwiches can you make? How many?
2 sandwiches.
2 sandwiches. Very good. If you have 3 pieces of meat and you have 4 pieces of bread, you know that the 4 pieces of bread could yield you 2 sandwiches. However, the 3 pieces of meat could yield you 3 sandwiches. Well, you could only make 2 at a max. Make sense? Okay, so simple logic. Now let's expand upon that and let's show that from a chemical perspective. And probably the best way to do that is just from an example. So I'm going to set you up with a problem, and I'll get you to copy it down, and we'll go on from there. Here we go. Good. 2H2 plus O2 to produce 2H2O. It says if you begin with 55.5 grams of H2 is how much you start with, and you start out with, let's say maybe 189.3 grams of O2. Let's say that you start off with both of those. So your problem might read something like you have 55.5 grams of H2 and 189.3 grams of O2. How many grams of O2, I'm sorry, of H2O, I apologize, can be made? And I also ask you for what is the limiting reactant. Now, when we look at that term limiting reactant, what does that sound like? Does that sound like the item that's in surplus or that's in low quantity?
I would say it's low quantity.
Okay, so whatever runs out first is your limiting reactant. Okay. Let you copy down this question real quick, and then we can move forward. Okay. So from here, what I would suggest that we want to look at is starting out with 55.5 grams of H2. Let's start out with 55.5 grams of H2. Good. And what we're going to do is we're going to do one of those dimensional analysis charts to take us from grams of H2 to grams of H2O, because we're supposed to find out how many grams of H2O can be made. So we're going to do the old school type of problem that you did on the quiz. We're just going to do it actually twice here in just a second. Okay, so walk me through this. What do I have to put on the bottom right here? Times 2. Okay. Grams of H2, right? And 1 mole of H2 goes on top. Someone totally different, tell me what I need to put on bottom right here.
1 mole.
No.
1 mole.
Very good. 2 moles.
All right, because there's a 2.
And then what goes on top? Someone totally different.
1.
2 moles
Why?
of H2O.
Oh, because there's 2 in front of them on the right side.
Yep.
Why don't I know
And then, what do I put in this last step? What goes on bottom here?
that? Of H2.
1 mole of H2O. What goes on top?
I put,
You probably want to be writing this down, dude.
1.
I'm not asking you to guess. I just want you to write this down, man.
Alright, it's the mass of H2.
Okay, which is 18.015 grams of H2O. Okay, so 55.5 divided by 2. So I'll let you put this in your calculator real quick. I want to see everyone hitting these buttons on the calculator, because I don't want to have an issue of like we can't calculate because we didn't have a price with the calculator. I want you to ask me questions. You get a problem with it.
How come you wouldn't? Huh. There's a grading error.
We can deal with it after class. We're in the middle of teaching this right now.
It's the exact same question,
Just,
though.
no, not right now. Please
Alright.
let me finish teaching this.
Yes, sir.
Okay. What number we get right there? I believe 495.9, so maybe about 496 or so grams of H2O. Is that correct? Okay. Now here's what I want you to do. I'm going to give you about 40 seconds. 40 sounds good. I want you to do 40 seconds, and I want you to take your 189.3 grams of O2, and I want you to do another dimensional analysis that takes it to H2O. So I want you to do a conversion that takes us from grams of O2 to grams of H2O. I want to see everybody working. About 32 or 31.998 grams of O2 on bottom, 1 mole of O2 on top. 1 mole of O2 on bottom for every 2 moles of H2O on top. 1 mole H2O on bottom. 18.015 grams of H2O on top. Is there anyone who... Yes, sir?
So we draw the map.
Sure. On both of these, well, actually on this bottom one, we'd be starting out with mass of O2, converting to moles of O2, then converting that over to moles of H2O, and then converting that up to grams or mass of H2O. And I would say that this would be a division by the molar mass, which is 31.998. I'm going to put a 1 and a 2 right there, bottom and top. And this is going to be a times 18.015 gram per mole. Now, with that map in mind, is there anyone who needs assistance on how I found numbers for the map? So we could find all those numbers, correct? Okay, so we really just ended up putting the division, then the bottom top, then the multiplication of 18.015. Both of my molar masses at this step and this step ended up opposite of 1 mole, just as we said last week. So we end up multiplying 189.3, dividing by 31.998 times 2 times 18.015. And my grand total on this is going to be 213.2 grams of H2O. Agreed? Now, I think you could agree that this question that we have thus far is basically a last week style question, right? Now, here's the style that we have that's a little bit different from what we did last week. Notice that in this problem, I didn't give you one mass, I gave you 2 masses. And I gave you a mass for each reactant. Did you see that? So maybe up to the top, wherever we wrote limiting reactants, we might want to remind ourselves that this is when we are given 2 reactant amounts. 1 for each reactant. Agreed? And we converted to the same product, which was no big deal in this case because H2O is our only product. We converted to H2O. And we were asked 2 questions. One question was, how much H2O can you make? Well, just like with our sandwich example, you could make the fewest number of sandwiches, which was 2. You can only make this many grams of H2O. 213.2 grams of H2O is your maximum output. Make sense? You can only circle the biggest number here. Layman's terms. Circle the biggest number right there. I'm sorry, the smallest number. I apologize. The smallest number is the one you go with. That's your answer. That's how much H2O you can make. Absolutely. And then we look at and we put a blame on this deficiency. This number is smaller because you started out with a number right here that was deficient. I would say that your O2, this number at the beginning right there, the 189.3 grams of O2, is the limiting reactant. There's the answer to your second question. Cool? So we want to make sure that we see what's up here. Good? Let's look at another example.
Will this be on the website?
I'm recording it right now, dude. Probably not tonight, though. Yeah, it won't run it that fast. draw out this question real quick. I'll give you the reaction. Now here's what